Hey, welcome to Love My Tool TV session with the master of all, Tony Fortunato, and I'm just back here as his wingman, and I'm Tim, the OCOM guy. So today we're going to talk about just some cool stuff, and one of our goals, someone asked me not too long ago, what's your goal when you do Love My Tool, whether it's Love My Tool TV or an article? And we try to do things that start the conversation, start the thought process. And that's what we're doing today. We're going to hit a couple of big things, and Tony's going to post all the slides so you can have access to them and copy them and put them on bathroom walls or whatever's appropriate for you. Today, gang, here's Tony, a great friend and a fellow technologist and just a super guy to work around. Too bad our other wingman, Churchill, the cat, is not available. So, Tony, take it away and let's talk today and have some fun.
Thanks, Tim. Hey, folks. Like Tim said, I'm Tony Fortunato. Thanks for a bit of your time. We're going to cover some Wireshark stuff we're going to start with, and we're going to end the conversation with some IOT and some security stuff. So Tim and I are running the show today. As always, we welcome all sorts of feedback. We got a lot of emails last time. So somebody even asked me via YouTube, how do I send feedback? I said, well, you can just, on the bottom of the show, you can add your comments. Or you can always go to my website, thetechfirm.com or lovemytool.com. And you can send feedback many different ways. And for the people who know me, obviously, you can email me direct. So let's get cracking. I'm going to share my screen. And while I'm doing that, I'm going to chat a little bit. So I was telling Tim, for some reason, the last few months, I've had an increased interest in Wireshark and automated captures. And then subsequently, when you have many files, how do you manage the files? What are some of the pros? What are some of the cons? So on and so on and so on. So in this case, I'm going to apologize inversely this time. I usually apologize if I spend too much time on my desktop doing stuff. But this time, I'm actually doing a few PowerPoint slides. So this is a little slide thing. As Tim said, we're going to post all this stuff. We'll have the links in the YouTube description, and we'll also have it on lovemytool.com. You can go get the files there shortly after the show. All right. So we got capture options. So with Wireshark version 2, this has changed a little bit, right? This whole layout has changed a little bit. And when you go to the Output tab, because obviously you want to control the output, it's very literal. So once you get your mind around the terminology, it's not that bad. You provide a name wherever you want to put this stuff. So it's important you understand the syntax and how things are laid out. As you can see, it shows you, C:, and there's a slash versus the backslash, right? We all know there's a difference. And it's important to understand how Wireshark wants to see it, not how you think it should work, just how their application guys did that. It doesn't matter if you think it's right or wrong. It's just the way it is. And there's a browse button. So worst case scenario, if you don't want to type and navigate through your various folders and stuff, just hit the browse button and you can go wherever you like. The browse button gives you an added feature that you cannot do when you just type a path. You can create a new folder, right? So if you were to type something in and the folder didn't exist, you have a problem, right? But if you use the browse button, you can create a new folder and you can drop the file in there. The second thing is, please make sure you put an extension, right? Either PCAP, PCAP, or PCAP-NG, but please make sure you put an extension. If you don't, then it won't have an extension, and if it's on your desktop and you try to double click on it, well, there's no file association for that, and you're going to have a problem, right? If you just go to Wireshark File Open, you're not going to have an issue, but just to make life easy for you, just please put an extension there. Down here, it even asks you, what format do you want, PCAP-NG versus PCAP? That might be another show topic in itself, is what are the differences between the two, some of the extra features we can do with the PCAP-NG that we cannot do with PCAP. And lastly, these two options down here, which we're not really going to cover right now. The other thing you might notice when you start typing in this path is down here at the bottom of the screen, the start button is grayed out. And it's funny, you watch technicians try to make this button work, and they just click harder, and that ain't gonna work. So basically, the reason why that typically happens is because in the Input tab, you did not select an interface. So that's kind of important to keep in mind. You know, as we work through tools, we kind of forget what we are, whatever. So please make sure if the Start button is not If it's grayed out, then please go select the adapter that you want to work on. So from there, you can create a new file. Well, the neat thing about this is if you want to start using these second two features, you can create a file name automatically. And in this case, I chose every 10 seconds. And you can see the file gets created every 10 seconds. Well, there's just a few notes here. The first thing is these files are just going to keep accumulating. They're just going to accumulate until your drive is full or until Wireshark, has a problem. Who knows? But the point is, when you want to work on these files, if you go within Wireshark file set, and then list files, you've got a little manager, a little file manager pops up. That's really important because sometimes the criteria might not be time-based. It may be size. And you got a 10 meg file. You don't know if that's an hour, 10 minutes. You really don't know. So this is kind of neat. It tells me the time this was created, right? This is the kind of start time, if you will. And modified is like the stop or saved time. So there's the range right there. So that first one, 15:19:35, 15:19:45, right? So that's 10 seconds, obviously. And that's kind of nice because if you say, oh, we had an error or something in the log and it was 15:19:40, which file is it? Well, you can use this to quickly find which file that is. The other thing that's important to keep in mind with your file sets is that there's a little, I'm going to call it a bug because it is, and every once in a while you may find a file set doesn't populate with all your file names. You'll find that, I've written an article about that already. It's been addressed. You may still have issues. If you do, don't worry, it's already been written up and you can work around it fairly easily. Well, sometimes you don't want the drive to fill up, okay? This is where we get into something called a ring buffer. So all we did here at the bottom is we added an extra criteria. The criteria was use a ring buffer with 5 files. That means I'm only going to have 5 files now. They're not going to accumulate forever. So this is important to understand. This means I have the last 5 files. So if you ever go to the analyzer and you stop it, you have the last 5 files. In this case, 10 seconds each means I have the last 50 seconds worth of data. Okay, that's important because sometimes you want the first 5, right? That's not what this is. So this is important to kind of have in your head what you want to accomplish. If you noticed, I've also used a fairly descriptive name. Don't be shy. People are still stuck with the old DOS 8-character .3 extension. No, just I'm not asking you to write a book, but just kind of be a little more descriptive. I promote this idea of having a trace file analysis book that specifies, hey, you probably should have a naming standard, right? Server SRV, Toronto TOR, Atlanta, like some kind of abbreviation for the city or the company name or the floor, the application. Just so when you look at this stuff, it makes more sense later. That's all. And it's also good for planning more than anything. Now, when you want a ring buffer to stop, that means you have the first 5 files. Then you're going to do an extra step. You're going to go to options and you're going to say stop the capture after 5 files. So that means I have the first 5 files as opposed to earlier when I had the last 5 files. It's a very subtle difference. That's why I'm kind of slowing down a little bit for everybody. And it's important you understand what you want. Sometimes you want the last 5 files because that's where the error was. For example, the disconnect, the application error, the whatever you want. In some cases, you want the first 5 files so you can see the session setup, the TCP SYN packets. I just wrote an article for network computing on that. There's things in there like the MSS, SAC, selective acknowledgments, all that kind of stuff that you only see at the beginning of the conversation. Right. Sometimes you want to see the application's 3-way handshake, SQL, its buffer size, maybe some authentication type traffic. That's at the beginning. So you have to decide, do you want the end, do you want the beginning? And sometimes you might say, I want both. Well, it doesn't work that way. So you're going to have to pick one or the other. You may have to redo the trace and do the other one, maybe the first 5, redo it and do the last 5, and that sort of thing, okay? But that's how you stop your analyzer. Now, just be careful. If you start clicking them all, it's going to stop when the first thing happens. So in this case, if I checked off the first one where it says 1 packets, well, it would stop pretty quick, right? The first packet would arrive and it would just stop. So these are not and, these are ors. So 1 or 5 or. So just please be careful on what you're clicking, because sometimes using your mouse or whatever you're doing, you can inadvertently click the other box, or you might be curious and forget, that sort of thing. All right, so now here's this is the meat of it. This is where the rubber meets the road. When you talk about ring buffers and you talk about creating these files, this is kind of like my little crude diagram, but it puts the point across pretty good. So here's file number 2, 3, 4, 5, and 6. And as you can see, here's our stream of data, 1, 2, 3, 4, 5, 6, 7, 8, 9, so on and so on and so on. Well, what the red signifies here, this kind of red or pink or maybe an orange, depending on your color calibration, this is showing me that when file 2 was stopped and saved, and then file 3 was started, there's that moment in time where we actually dropped, in this case, 1 letter. Now, depending on the load of the network, how much data you're trying to capture, and based on the speed of your machine trying to capture the packets, this may be 1 character, it might be 1 meg, it could be 100 meg. We don't know, you didn't get it. How do you know what you didn't get? You don't. But the symptom here is going to be later on, if you try to put these files together, Wireshark might complain that you're missing packets, right? And this is kind of the questions I get from people. So just be aware that when you do these ring buffers, you have these little gaps in time. Now, if I was set up my analyzer and I just watched Tim and said, hey, Tim, log into your Outlook and surf the net and that kind of thing, this little brief moment of time, based on the fact this is an interactive baseline and the human is driving, I'm probably not going to miss anything, probably, right? But again, if I said, hey, Tim, stream a YouTube video in high def, and then yeah, I'm going to be missing more. And oh, let's capture all the data in and out of the router port. Well, now you've got more data. It's an aggregation device, right? So the point is you have to kind of understand where you're capturing. Now, this goes into a whole other topic Tim and I just briefly talked about a little just off air. And that's the fact that your machine is your machine. It's your laptop. It's your desktop. It's whatever you're capturing with. So you have to be aware of a few things. Number one, you're only as fast as your slowest thing. So if your slowest thing is going to be your hard drive, well, then that's your slowest thing. So try to stay away from slow things like USB 2.0 or 1.0. And I have people doing that. They'll plug a flash drive in or a USB drive right into your PC and start capturing to that drive. That's not a great idea, right? The best way to handle that is just do it all local and then copy it later to the flash drive or to the network drive or whatever you're trying to do. When it comes to drive technologies, obviously SSD versus some sort of disk technology, there's inherent differences with that as well. And if you don't understand all of this, you really have to be careful, right? Because this is just another piece of software. And that's the other thing. This is also reliant on how your machine is configured as far as its software goes with things like firewalls, antivirus, all the things on your machine, especially with some corporate builds. You know as well as I do, the machines are a bit laggy because they have all this corporate stuff on it. And I was telling Tim, some of my more larger corporate customers actually have software removed from laptops, and they use them specifically for troubleshooting. And they know that this is not something that's going to be plugged into the corporate network for email and surfing. This is just to troubleshoot and put out fires, that sort of thing. You might want to consider that. And even for curiosity's sake, you might want to just try that. Capture some packets with a vanilla machine versus one with all your corporate stuff on there. Just please be aware, because this can get you in a lot of trouble.
Well, embarrass you pretty badly.
Yeah, that's right. And we don't need that. So the last thing that I try to get into when we talk about capturing packets and automation is a very simple concept you may be familiar with, and that's using the command line to automate. I've had people try to automate Wireshark using a GUI automation tasks, which can be a bit of a problem. But in this case, I'm just asking you to try the command prompt. And when you go to the command prompt, the two big ones you're going to try is tshark and dump cap. That could be a show in itself, so I'm not going to get into it too much. All you need to know is that tshark uses dump cap, as you can see from my screenshot, to capture packets. So some people say, well, let's cut out the middleman and go straight to dump cap, and that's fine. There are some subtle differences with the options. So I just ask people, if you can get away with using dump cap with whatever you're trying to accomplish, then I try that first. There are some specific T-Shark options that you want to use that you just can't do with dump cap, fine. But once you get it all sorted out, then you can put this in a batch file. You can put it in a schedule, like scheduler. You can do whatever you want. I've even had some customers, basically, when you turn on a machine, in the startup folder, guess what? There's this batch file that starts up and starts capturing packets every 500 meg. And it just keeps going and saves 5 gigs worth. And it's always on the machine. So you turn it on, it's kind of like a remote probe, if you will, and it's just constantly capturing the packets. Just to make the machine quite quick, we get into the whole architecture thing where you have a computer with 2 adapters, one doing all the heavy lifting and one for you to access it. In the old days, we used to call those monitor and transport, or management and network, depending on the vendor. And you can do that with your PC very easily because you have Wi-Fi and Ethernet, for example, on your laptop. Well, have Ethernet do all the work and then connect to your laptop using your Wi-Fi. What that means is I can go to my Ethernet card and take all the protocols off of it now, right? And that way it's not talking on the network as well. So there's many different ways of architecting your computer just so you understand how it's behaving. And by doing that, then you can trust the data a little bit better. I've written a few articles talking about traffic generation and how switches affect it, taps affect it, and all that kind of stuff. Well, your PC is going to affect it as well. So this is really important you understand. And the worst scenario I've seen so far that makes me cringe are people running Wireshark within virtual machines. You know, I'm not telling you that's a bad thing, generally speaking, but that makes me cringe because there's so many things that can go wrong because now you've piled the software on the software on the software, and it's just a big Jenga tower ready to come down, right?
Yep.
Okay, and then the last thing here is once you have a bigger file, because that's one thing you might want to consider, instead of 5 smaller files, maybe have 1 large file, you know, as large as you can kind of handle. But by having a large file, you might find Wireshark might not be able to open it. This is where a little utility you have already with Wireshark called Edit Cap comes in. So what Edit Cap allows me to do is chop up this big file. So in this case, in this example, this first example, I'm going to split this file called 3 minutes into 20-second trace files. And that's exactly what we did here. So edit cap-I 20 for 20 seconds. The file that's in is 3 min, and the file coming out is 20 secs. Obviously, it will number them individually using month, day, year, and time as a prefix, and you'll actually see that you'll end up with many files. I've done this many times. It's super fast, and it's kind of funny. First time I did it, I hit enter, and it returned immediately to the command prompt. And I did it again and again and again, and guess what? I created a pile of files because they were already there anyways, right? Because I'm thick that way. So that's something you might want to consider. And the last thing about dealing with large files is something I've mentioned the first time that people found quite interesting, and that's called packet slicing. So packet slicing is simply me taking this file, or these packets, these frames, and only saving the first so many bytes. In this case, I did 128 bytes. 128 bytes will give you the MAC address, the IP, the TCP or UDP, and a bit of the application header. You can do less than that if you like. You can do more than that. But by doing that, now the trace file has become incredibly smaller than it first started with. And you know, I've reduced trace files 50, 60, 70% just by simply using this trick. The reason why you might want to consider this, there's 2 big reasons. The first thing is you might never, ever be able to read the data. For example, it may be encrypted, and you're never going to be able to see it, so why are you saving all that extra data? And secondly, legally, you might not be able to save the data, so you might want to consider slicing the data as well.
You may not even be allowed to look at the data. That's a big priority today.
Yeah, exactly. All right. So that's I'm going to say that's Wireshark in a nutshell. What I want to do is I'm just going to go to my command prompt just for one moment, just to finish the thought, and then share this. Let me share my application window. There you go. As you notice, I'm old school, so I've got that cool black and lovely green happening. And the biggest question people ask is, T-Shark, it's very overwhelming. How do I get started? Well, T-Shark -- will give you a shopping list of all the stuff it can do. I'm telling you right now, this is not as overwhelming as you would think. If you look at that capture options screen that I was showing you earlier, everything on that screen plus more is reflected here. So all you need to do is look at the screen, what do you want to do, and then look in here and find out what the corresponding options are. And just a little bit of trial and error and you'll figure it out. I've got lots of examples on my website and Love My Tool that you can look at. But the big one you start with is -D. That's going to give you a list of all your adapters. These could be virtual, such as VMware. These could be, physical, like Ethernet or Wi-Fi. These could be logical. These could be VPN, whatever. So from there, I want to capture from files. So I'm going to choose an interface. So -I space and the one that I'm using. In this case, I'm going to use my Ethernet Killer Gig, which is number 4 on the hit parade. So I just simply do -I4, and that's it, enter. And when I do that, it's going to just spit a bunch of stuff on the screen. And this is obviously the data from our broadcast, right? So I'm just going to stop the capture. Good old Control-C is your friend. You're going to stop that. And it says 2,908 packets captured. Well, no. They aren't captured literally to a file. They are captured on the screen. And that's what's important. This is kind of a programming terminology more than anything. So the last thing you might want to do is say, well, that's nice, but I want to actually save this somewhere. Well, -W means write to a file. Testing. If I can type right, 123.pcap. Enter. Now you notice I get an error. Permission denied because I'm in the System32 directory. So this is where you got to learn a little bit about your machine. I had people set these things up, walk away, and they didn't have one file created because of something like this. So this is what I try to get people to understand. Walk through this manually, okay? So I'm going to go to a folder that I know I can write to. I'm going to pull up my last command. I'm going to hit enter, and off we go to the races. Well, now I don't see the packets anymore. I see a packet counter, right? Control-C, stop. And now I've got my file. Testing 1, 2, 3. Good to go. So this is kind of important that you know how to walk through the basics before you try to automate anything, especially if you're using filters. The last thing I'll show you, because I know I'm running short on time, is good old dump cap, the same thing I told you about. Dump cap -D, same thing. Then I can do dump cap -I, and again, I'll do the same thing. Ethernet Killer Gig is number 4, same thing, enter. But this time it's different. Look, it's automatically creating a file in my temp folder. You see that? And a packet counter. So that's kind of cool. So right off the bat, just basically running the two by default, you see there's a difference already. Okay, and that's it. So again, I don't want to take too much of Tim's time up, but there you go.
Take as much time as you need. What people have to understand also, Tony, is that every time you touch a packet, you touch anything electronically, not to mention dynamically like in time and space, you change it. So what you look for, and what I think Gerald's done an incredible job of, is Wireshark tries to balance relative time, okay? Which means that frame to frame, it's relatively correct. Now, a lot of people, I've had people call me up and say, there's no way that that second frame took an extra 100 milliseconds to get there. Well, you've got to remember, you've got an interframe gap, okay, which is 96 bits, okay, and then you could have any number of other things going on, okay, inside your network that you're not going to be able to see with Wireshark or any software-based computer unless you're using a fully promiscuous modem access. And 99.99999% of computers you buy do not have promiscuous modems in them,
right.
Okay, because the bus can't handle it. And then on top of that, as you're talking about, to do a good benchmark on your system, it's tough because you've got all kinds of dynamic delays in your system. So, you know, what's the old adage? Don't believe it unless you've got it in writing, and even then I would question it. Okay, because it just you never know. And Gerald's done a great job. Now, by the way, one thing I will say is if you ever find a problem in Wireshark, let Gerald know right away by going on the Wireshark.org. And Gerald's a maniac when it comes to getting things fixed. He likes everything to be spitbot, and he's done a hell of a job building and giving to the world Wireshark. Tremendous job. So think of it from that perspective. You'll have a blast. By the way, the other thing is I had a customer or a guy one time was telling me that he got all kinds of weird delays when he was using his Wireshark and seeing all kinds of stuff that he didn't understand. And so I told him, I said, well, let's go look at what you're seeing, just the chatter that your computer is doing. And about 12% of his traffic was IPv6 advertisements. Now that's pretty high. And it was high because of the environment he was in, because ICMPv3 is very chatty. And if you want to play with someone's brain, you just go out and start, looking at all the stuff that goes over your network, and you will be not pleasantly surprised. You may be totally PO'd about it. A lot of stuff that you put on there that you really shouldn't have to put up with.
And just to finish Tim's thought, the Wireshark bug database is bugs.wireshark.org, and it's Bugzilla. It's right on the wireshark.org website when you go to support. And I've submitted bugs, but I think more importantly, you don't have to submit a bug. Whatever you find that's weird, I'm gonna throw something, a little challenge out at you. If you ever type that in as a bug, like whatever you find that Wireshark's doing that you don't understand, and it really is a bug, I'll almost guarantee you that somebody's beat you to it. And that happens a lot. It's almost like a competition. And I'm going to say very rarely have I found something that nobody's reported yet. It does happen, but I'm not going to say it happens all the time. So the bug database is a good place to go.
And you'll usually, if it's not a weekend, you'll see a resolution in, I've seen it in minutes, not hours and not days, but minutes. Yep. They jump on it like ducks on a June bug. So they're, they really want to make this work. So, and Gerald and his team have done an incredible job. So, so we're going to talk about IoT. So what I did is I took a presentation that I put together that I taught over at Kennesaw University, and decided that we would talk a little bit about it because from my perspective, it's extremely scary. Okay. The amount of stuff that's going on that you really have no visibility into unless you actually decide to look at it, and then you probably will make you feel like Halloween has come to your network. Go ahead, Tony. So we put a bunch of slides out here. Tony's going to put them on the website so you can go read them individually, and I'm going to go through them pretty quick, like in 5 minutes. What is IoT? Internet of Things. I call it the Internet of Thugs because they try to take over. They try to rob your bandwidth. It's incredible amount of stuff that they do. There are too many things that are using IoT, and it's really kind of a great routing program. As one friend of mine said, who's a black hat, he said, if I was to choose the very best application for using bandwidth, I would point to IoT. And by the way, if you get into IoT at all, forget everything you know about networking today. It is 100% different. There's not hardly anything except for the Ethernet frame size itself. It's totally unregulated. It's truly the wild, wild west. We hear people talk about that we only use a few % of the actual internet, and the black or dark web uses a lot more of it than we do. You're going to find out that IoT uses a lot of it, and it can control our homes, our everything. Okay. And this is a great example. Every system that you buy today probably has an IoT device in it, including your TV, your washer, your toilet, your garage door opener. Of course, the IoT in your car is constantly active. Your refrigerator, your stove. Okay. All of these things have some kind of connectivity. And I put in there in the gateway, Bluetooth, low bandwidth IPv6, basic Wi-Fi, Zigbee. Now, Wi-Fi has 2 and 5 gig capabilities. So, and that's only a few of the access technologies that can help an IoT device get to the internet. And the latest really big internet attack actually used thousands of IoT devices that really should not have been available, but they were very easily turned into bots to attack the network. And it says there in bottom, without any permission. So what I did is I kind of put together, go ahead, Tony. I put together some of the layers. Now, this is not by any stretch of the imagination all of the components. So you've got the infrastructure, physical layer, basically. You got the method of ID. You got different comms and transport methodologies, discovery devices that go out and try to dig in and get access through anything you got. I have a friend of mine that told me that his brand new TV was communicating with his car. Every time he started his car up for a few minutes, the IoT device from his TV was trying to send information back to the manufacturer through his car. Data protocols, device management methodology, semantics, control, languages, multi-layer frameworks. And as you note at the bottom, these are only about 10% of the known layer methods and access technologies. And only about 20% of all of those are any kind of definition of a standard. So if you thought IPv6 was standard crazy, IoT makes IPv6 look like a kindergartner. Next, Tony. So I'm not going to go through this, but IoT security issues, open access to hack and bot. We saw that in the Miri's scores attack of the web lately. They're, so easy to get through. It's amazing. There's no easy way to track. There's no easy way to stop and block them because most of them root into the network and have unlimited access, unfeathered access, and just completely ignore anything else. Hit it, Tony. What they did in that last attack, and I'm not going to go through all this, but they did a DDoS using DNS amplification, using simple IoT devices that should not send out very many frames or very large frames. But by using the DNS amplification method, they were able to send out packets that were on an average of 512 up sizes by creating false UDP responses and TCP reversions. So yeah, IoT devices are as dangerous as they can be. And these are DDoS attack needs. About 90% plus of the IoT devices have a password but they're mostly all in factory mode. So like when you do something with like SCADA or industrial control, probably about 50 or 60% of the control devices managements out there either don't have any kind of password, or it's Honeywell or Siemens.
And
so
Tim,
these are just
some of these devices also have built-in, burned-in user IDs and passwords that you just cannot get rid of or change.
That's right. A friend of mine and I have decided the only way to stop IoT devices is find them on the device and take them out. Now they're making it very hard. Up to now, they've been using a special card, like a NIC card with an antenna on it. But now they're going to start integrating it actually into the board. So finding it may be hard. So, but if you see an antenna, cut the bugger. Next. So the technical future of IoT. IPv4, of course, has limited address, so we can't have, every square foot of the world with an IP address. If we ever do get a true IPv6 environment, I live in Georgia and we have a plant we call kudzu. And if you want to give kudzu a challenge, you plant it in soft concrete, let the concrete dry, and it'll grow anyway. You can't kill the stuff. IoT devices can be attacked very easily, especially through their ICMPv3 neighborhood advertisements. They have so many different RF access technologies there's virtually no security or protection. We don't know the amount of data collected, how it's shared, and there's very, very little technical information on the IoT invasion. So you're going to have to dig a little bit. Next. He's so good. So summary, it's not, IoT is not controlled, not secure. It's a power struggle to overtake all the bandwidth. There's so many different access methods. You lose your privacy, you lose control. We do not, the ability to hide it and take and send unknown information is terrible. It's easy to bot, and like you said, Tony, most of them have factory built-in passwords that can't be changed. So they're very easy to get access to, and they're extremely vulnerable by a myriad number of IPv4 and IP6 version attacks. Hit it. The future, manufacturers are pushing for inclusion in everything. And I'm not joking when I say here that a toilet, a friend of mine in Japan recently told me that he was building a new house and he bought a toilet. He did not buy the gold-plated one, but he did buy the other one. It was about 9,000 American dollars, and it actually had 2 cameras. It measured the amount of sugar in their urine and did a whole bunch of other things, and reported back to your doctor or to a medical distribution center. Yeah, I've seen them on refrigerators. I've seen them on freezers, TVs. I even had a buddy of mine bought a computer that, and I got to find out what kind it was. It was like a tablet for a prison system, and it actually had IoT built into it, and it was running over the Wi-Fi, and it would also scab the other Wi-Fi. So if the Wi-Fi was busy on the device, it would scab any open Wi-Fi it could get a hold of. Even security application. A friend of mine bought one of these new electronic in-home security systems, which are really not very secure. And he found that it had an IoT spiel that it would go through to tell the manufacturer how it was being used, when it was turned on, etc. We need to demand the ability to not have it or to be able to turn it off. Okay, we need to be able to control access, control the information being shared. We even found a TV set not too long ago that actually shares the audio that they hear in the room while the TV's on. So my last slide that Tony took down was, we got to question things to make changes. Answers don't help. Answers finalize stuff. And Tony's the expert at asking the questions, and we need to do that. We need to ask the questions so we can move forward. Never stop asking questions. Thank you guys for sharing a wonderful time with Tony. I love working with Tony. Actually, I'm going to get to see him pretty soon. He's going to come down to Georgia. We're going to make him a Southerner pretty soon. He'll quit saying "hey."
Yeehaw.
And he'll start saying "y'all." You're going to get him fixed. You're going to get him fixed.
You're going to get me fixed. Just a quick.
No, I don't mean that. That was Sue's job.
I guess a quick note. That was great. I will post this stuff. And one little thing that I just thought of that I told a few of my friends when they asked, is my stuff safe? I said, well, one thing you can do is whatever you have, your webcam or baby monitor, whatever it happens to be, if you go to that vendor's website, go to their support and download section, see if they have a current update to their software, their firmware. Maybe they do. I also tell a lot of my friends before they buy things, like a really good example is a webcam. One of my friends was going to buy an HD webcam. I went to that vendor's website, and it was just a piece of garbage. It was not helpful at all, and there was no firmware updates or software updates or support for them. And I said, that's not a good product to buy. So this is a good example of doing just a few minutes of homework. I'm not asking you to spend hours of your life doing this, right? But as I said, if people can spend 3 hours trying to find out which taco truck has the best food, they can surely spend a good 10, 15 minutes trying to figure out if whatever they're going to buy is going to be worthwhile. And I'll tell you a personal story. I bought a garage door opener. It's a brand new one. It's a good one from Ryobi that I tend to like, but it also has Wi-Fi, but I haven't enabled it yet because I can't find any good documentation on it. So I don't need Wi-Fi on my garage door opener, so it's not even enabled right now. And I made sure, and it's not. But you should just take a few minutes to be aware. That's all I'm saying.
Right. I concur. Wake up, ask the questions, and if people can't answer them, don't settle for that.
Yep.
So I've got to know before I'm going to buy anything from you, Jack. So, you know, don't tell me you don't know. If you don't know, you better find out pretty quick.
Cool. All right. So we're going to cut this show in over a few minutes, but it was all good stuff. Thank you very much, Tim. And
oh, you too, Tony. Thanks for everything, buddy. I'm really glad we've got you on. We're trying to keep you out of trouble. Sue's paying extra for that, so we're delighted. And yeah, so it's just a lot of fun to have you around.
All right, guys. I'll see you guys on the next show. Have a good day. Bye for now.
Be safe, everybody. Bye.